No, just hang on. I just want to make sure it goes through to Zoom after YouTube. Otherwise, I'll record it. But just hang on. Okay, you can start.
Good morning, good people. My name is Hendrik Makaneta, and as always, let me take this opportunity to welcome you once again to our grade 9 mathematics. And of course, those who may want to follow me, they can follow me on Twitter at Hendrik Makane3. And the topic for today is construction of geometric figures. And this is the final part of our lesson on construction. And of course, by the end of this lesson, learners should be able to investigate properties of geometric figures, by exploring the minimum conditions for triangles to be congruent, but also to investigate diagonals in quadrilaterals. We are going to zoom directly into the first part of our triangle. And this is the first activity which I want to give out to learners. I want us to construct a triangle PTD. As you can see there, TD should be 7 centimeters and PT should be 6 centimeters. And the angle PTD should be 55 degrees. And of course, I want you to also construct a triangle KMB, where angle KMB is also 55 degrees, MB 7 centimeters, and of course KM 6 centimeters. Now, trace the two triangles that you have constructed on a loose sheet of paper and neatly cut out the traced triangle. Now, this is an activity for today, and I hope that learners out there are able to follow the instruction, which is as follows. You need to firstly draw a rough sketch, just a rough sketch of the triangles. And then, of course, follow the instructions as I've put them on the board. I know that I've just moved faster. I'll just go back to the previous slides just so that you see the question, the activity, where you need to construct the two triangles. And of course, the first triangle, as I've said, it has got a length of TD. That is triangle PTD. The length is 7 centimeters. And that is TD. PT will be 6 centimeters. And of course, angle PTD will be 55 degrees. I hope that I'm visible to all. If in case you can't hear me properly, please feel free to raise up your hand. And the same goes for triangle KMB with KM equal to 6 centimeters, angle KMB equal to 55 degrees, and MB will be 7 centimeters. Now, once you have constructed these two triangles, you need to trace them and neatly cut out the traced triangle so that you can be able to check congruency there between the two triangles. Remember that when we say that the triangles are congruent, this actually means they've got the same shape and the same size. So that is congruency. Don't confuse congruency with similarity. Similar triangles have got the same shape, but different size. Congruent triangles, same shape, same size. And of course, I've also given you the instructions which you can follow to draw the rough sketch, but also to construct those two triangles. Now, I think we've been now wasted a minute on this. Perhaps just to give you the last 30 seconds to finish your triangles. Of course, if you still need to look at the activity, you can look at the activity there. In the next minute, then we can proceed. Right. Where do we go now? We have now constructed, I believe, triangle PTD and triangle KMB. If you've done your work correctly, you should come up with a diagram like this. I'm sure that this should be the first one. You can see we've got triangle PTD. And PT, as I've indicated, is 6 centimeters. And TD is 7 centimeters. You can also see the angle there, PTD. Angle PTD is 55 degrees. And if you have drawn your triangle correctly, you should be able to have a structure like of this nature. And of course, once you cut out the other triangle and paste it on top of this PTD, you will see that the two triangles will be exactly the same size as well as the same shape. Because basically we've given you the same length, two of those, and the same angle for the two triangles. So you should be able to see by now that the two triangles will be congruent, meaning that they will have the same shape and the same size. And of course, that is what we mean when we talk about construction of triangles, particularly the concept of congruency. Right, I'm proceeding to the next one now. We have 3 triangles in our list here, and you've got a table at the bottom. In the table, you can see on the left column, you've got the statement there, and the right-hand column, you've got the reason. And I've given you 3 triangles. And now the question that I want to ask you now, just to engage you on this activity, is that which triangle is congruent to triangle PQR? I want you to look at the 2 triangles carefully. That is triangle ABC and triangle DEF. Those 2 triangles, I want you to observe them carefully and raise up a hand and tell me which triangle is congruent to triangle PQR. Lee, your hand is up. Can we hear your comment, Lee?
Can you hear me?
Yes, I can hear you.
It is triangle DEF.
Triangle DEF. And why do you say that? Why did you choose DEF and not ABC?
Because like if you look at the triangle QPR, the 2 long sides has like the marks on them. Where in triangle ABC, it's 1 long side and 1 short side. That's why.
Exactly. Thank you very much for your comment.
Pleasure.
Yes. Now to add to what Lee has just said, if you look closely to the 2 triangles, ABC, triangle ABC and triangle DEF, you'll be able to see that we've got 2 long sides. And now the 2 long sides in PQR, are marked as Lee has said, as well as DEF. If you look at DEF, the two long sides there are also marked. But in ABC, only one long side is marked, and the second long side is not marked. That is AC. AC is not marked. So only BC is marked. Therefore, D is correct to say that DEF is congruent to triangle PQR. So thank you very much indeed, Lee. Just to take you back again, you will be able to see that this is one of the triangles that I said we must draw initially. And together with its corresponding triangle, which was triangle KMP. Remember, I said you must construct triangle PTD as well as triangle KMP. And once you have constructed them, because they will have two sides. The first side will be 7 centimeters, the other side 6 centimeters, and with an angle 55 degrees. They are not different. These two triangles are not different from the one that we just had now. You will see that you've got two sides, you've got an angle. So usually in geometry, you will say this is a side, angle, side. So you have a side, an angle, and a side. Exactly as we have in this activity which we have just done, where Lee was able to tell us that DEF is congruent to triangle PQR. So that is how far it goes in as far as the triangles are concerned. And without any waste of time, I'm going to zoom. Remember, in the beginning, I said that we are going to look at both triangles as well as quadrilaterals. So I think that for the purposes of today, we will limit our triangles only to congruence. And of course, the next question will be to look at quadrilaterals as well. Now let's go and look at quads. Of course, this was just the answer that DEF is congruent to triangle PQR. The reason being side, angle, side, as Lee has just said. Now let's go to quadrilaterals in the same example. Maybe to start, let me pose a question to you. What is a quadrilateral? Banjwa, your hand is up. Banjwa.
It's a four-sided angle, like shape.
Exactly. It's actually a four-sided figure. Yes, thank you very much indeed, Banjwa. A quadrilateral is a four-sided figure. So whereas a triangle is a three-sided figure, a quadrilateral is a four-sided figure. So meaning that any diagram that you see which has got four sides, that diagram is known as a quadrilateral. Right. And of course, today we are focusing on the diagonals of rectangles, a square, parallelograms, you know, as well as a rhombi or rhombus if it's one. If it's more than one, then it will be rhombi. Right. Let us carefully look at the following quadrilaterals. I've got 4 quadrilaterals in the board, and I want you to carefully observe all of those 4, because I'm going to ask you a question. I do note that the first quadrilateral there are 2 points G. As you can see, you know, it should have been G, H, I, and J. But it's not a problem. The quadrilateral is very clear. Don't mind the angles. Now, I'm going to ask you a question. Which of the above quadrilaterals is a rhombus and why? So I've got 4 quadrilaterals. I want you to tell me which of these are, or which of these is a quadrilateral. It's a rhombus. in particular. And once you have given me, I'll just note two hands. The first person must tell me which one is a rhombus. And the second person must tell me why. Right. We've got two participants. Your hands are up. One of you can come in. Lee, is your hand up? Bajwa, yes. Bajwa, let's go back to Bajwa.
ABCD is a rhombus because, ABC, D.
Okay, thank you very much indeed, Bajwa. Now, let's go to the next hand now. Next hand. I don't see the next hand there. I see there are two more participants whose hands are up.
J, M, K, and L is a rhombus because M and L is parallel to each other and a rhombus has two parallel pieces.
So you say, who's speaking now? What's your name? Chantel, is that Chantel? Okay, let's go to Chantel lastly. Can we have a comment by Chantel? Chantel C.
The rhombus is J, K, M, and L because M and L is parallel and the rhombus has two parallel.
Okay, so, all right, thank you for your comment. Now, that was Chantel and Bajwa. All right, Bajwa said that A, B, C, D is a rhombus. And Chantel has just made an addition. Chantel, you have just said J, K, L, M is also a rhombus. Now, let me start by marking Bajwa correct. Bajwa, you are correct when you say A, B, C, D is a rhombus. But Chantel, I want you to look carefully at J, K, L, M and look at the sides. We've got two pairs of parallel lines. But if you look at those parallel lines, you know, we don't have, there's nowhere where it's indicated that all the sides are equal. But if you look at A, B, C, D, those lines there, in AD, AB, BC, and CD, indicate that all the sides are equal. Now, one of the properties of a rhombus is that all four sides should be equal. That is why I'm saying, and Bajwa is correct when he says A, B, C, D is a rhombus. So you need to look at the properties of a rhombus. You need to learn and understand the properties of a rhombus. And in this case, the rhombus, one of the properties of the rhombus is that all sides, all four sides are equal. Now, Chantel, if you look at J, K, L, M, not all four sides are equal. You are only given, you are only told that the sides are parallel. JK is parallel to ML, and JM is parallel to KL. So that is the only information that you have. You are not given any further information. So at this stage, you don't know whether the four sides are equal or not equal. You only know that the two sides are parallel, and the other pair of sides is also parallel to each other. Therefore, you cannot conclude that JKLM is a rhombus. I hope that it makes sense. But we can conclude that A, B, C, D is a rhombus because we are given the information that all four sides are equal. I hope that it makes sense at this point. Now, as you can see, we agree with Bajwa that A, B, C, D is a rhombus because all sides are equal. All four sides are equal. I'm going to now move to the next slide. I want us to construct two intersecting circles. Now, to construct 2 circles, you're going to use your instruments now to construct 2 circles. But each of these circles must have a radius, meaning that the radius of each circle must be 6 centimeters. I hope that everyone can see out there. I hope that these instructions are clear. And thereafter, you have to label the center. You know, each circle must have a center, and the center of the first circle must be F, and the center of the second circle must be G. But equally, I want us to label the points of intersection. And then thereafter, the points of intersection, N in this case, and of course, that will be N and D. Once you have done this, you need to draw the line segments that can join N to G, G to D, and D to N. So that at the end of the day, you can have a quadrilateral there, meaning that you're going to have a 4-sided figure. And this 4-sided figure should be called FNDD. Once you have this 4-sided figure, then you can draw the diagonals of this quadrilateral, and you can call their point of intersection K. So you have 2 diagonals in this case, which will meet. And the point of their meeting, or the point of their intersection, is called K, just as we have done. So I've given you the instruction there. Constructing 2 circles, they must each have the radius, which is 6 centimeters. And of course, label the centers of the circles. The first circle there, the center will be S, and the second circle, the center will be G. Now, label again the points of intersection, that will be N and D, and thereafter draw a line segment which will join F to N, N to G, D to D, and D to F. So that eventually you can form a quadrilateral known as FNGD. Thereafter, what I want you to do now is to draw diagonals of this quadrilateral and call their point of intersection K. I hope that you are busy now constructing these 2 circles. You should be done with the construction of 2 circles by now. But I also want you to realize that the radius of each circle is 6 centimeters. By the way, when we talk of a radius, we talk of a line that moves from the center of the circle to the circumference of the circle. That is what we mean. Don't confuse a radius with a diameter. Radius moves from the center of the circle to the circumference of the circle. And thereafter, as I've indicated, you draw the line segment that join F to N, as well as N to G. And of course, you also connect G and D, as well as D and F. Once you have added all of this, you will be able to see that we will now have a quadrilateral, which will be known as F, N, G, and T. So that will be a 4-sided figure. At this point of the 4-sided figure, you need to now draw the diagonals of this quadrilateral. I hope that you are completing the task as we speak. You need to draw now the diagonals of this quadrilateral and call their point of intersection K. I hope that I'm not moving fast. I would like to move from this slide, but I equally, I just want to give you a few, seconds just to finish. Adam, your hand is up. Let's hear you.
Hello? Hello?
Yes, go ahead.
So how are you supposed to go from two intersecting circles to a quadrilateral?
Well, what do you mean? What do you do? You draw, you construct two intersecting circles. I'm sure that should not be a difficult. Now, once you've done that, remember each circle must have a radius of 6 centimeters.
Yes.
So you must label the centers. So the starting point is to label each center. Once you have drawn the two circles, you label the center of each circle. The first center, you name it F, and the second center, you name it G.
Okay.
Right. Now, that should be easy.
Yeah.
Now, listen carefully now. Once you have labeled your centers, F and G respectively, you now go to the points of intersection of the two circles. Remember, I said that you construct two intersecting circles. So where they meet, where the two circles meet, they will meet at 2 points. I'm sure you agree with me.
Yes.
Yes. Now the first point will be N, and the second point will be D. So you label those points.
Okay.
Once you've done that, now you can draw the line that joins F to F, meaning that you are moving now from the center of the first circle to the point of intersection F, the first point of intersection. Thereafter, you move from the second center in the second circle, you move from point G to point D. That is the second point of intersection.
Okay. Okay, so basically, yeah, okay, cool, I understand.
Yes, now you will have 4 points. The first 2 points will be the centers of the second, and then it will be the intersections, the two intersections. So you've got two centers, you've got two intersections. Now you join all of those 4 points.
Okay, thank you, sir.
Thank you very much, indeed. It should be clear at this point. I hope that it's clearer to all the learners now. Now, once you've done your work, you should be able to come up with a structure of this nature. I hope that everyone can see what I was talking about, what I was referring to. Now you can see we have got two circles which intersect each other. Now the first thing that I was just talking to Lee about now is the centers of the two circles. The first center, as I've indicated, is F in the first circle. That is the center of the circle. And the center of the second circle will be G. I'm sure you can see G on the screen now. And now let's go to the points of intersection where the two circles meet. The first interaction where the two circles meet is N. And of course, the second intersection is D. That is where the circles cut each other, intersect, where they meet. Point of intersection. Now at this point, once you have got all the 4 points, you join them together. So you join F and D. Then you join D and G. Thereafter you join G and N, and thereafter N and F. At this point, it should be very clear now that you have a 4-sided figure. But you don't end there. What do? You draw the diagonals of the quadrilateral. So there will be 2 diagonals. Every 4-sided figure, every quadrilateral has got only 2 diagonals, meaning that you cut that quadrilateral into 2 equal parts or into 2 halves. The first diagonal will be MD. The second diagonal is FG, as you can see in the picture. And where the 2 diagonals meet, that point of intersection, we call it K. This is what you should have once you have followed all the instructions. Now I'm proceeding to the next slide with a question. And I'm going to pose this question to you. What type of a quadrilateral is this? And please give reason for your answer. Adam, sorry I called you Lee the other time. Adam, please go ahead. What type of a quadrilateral is this? Are you there, Adam?
Hello?
All right. Who's speaking now?
Adam.
Yes. Please go ahead.
It's a square, sir.
It's a square.
Yeah.
Why do you say it's a square?
Because if you turn the shape to its bottom side, the shape isn't squished or like turned. It's straight all around, and each side is the same length.
Each side is the same length. How do you know it's the same length? Maybe tell us. How do you know sides are equal?
Visually.
Or visually?
Yeah.
So you did that by inspection?
Yeah.
Okay, but okay, fine. It's good to also, you know, look at the properties by inspection or
Yes,
just that visually, as you said. But in this case, I want a concrete reason. But let me pause for now. Let's go to another learner, Adam. You are right. Let me say you are correct when you say this is a square.
Okay.
But your reason is not good enough to say you've just done that by inspection. Inspection, you know, you can't just inspect. In mathematics, we want to calculate. We need to give concrete answers to say, we have calculated this and this is the right side. So thank you, Adam. I see there are 2 more participants. Can we go to another learner? Can we get another learner? Anyone at all? All right, Tino, let's go to Tino. No, please go ahead.
Sir, I think
Tino?
that it's you know.
I see your hand is up, Tino.
Yes, sir. I think that it is good because all the sides are equal, sir. Hello, sir. Hello, sir.
It's a square. Why do we say it's a square? Because FDGN is a square because if you look at FD is your radius. It's a line that moves from the center of the circle to the circumference of the circle. And DG is also a radius. Remember what I said initially when I started. I said the radius of each circle must be 6 centimeters. What does that tell us? This actually tells us that the 2 circles are equal because each circle has got the same length of a radius. So FD is equal to DG. And what is the size of FD? The size of FD is 6 centimeters. DG is also 6 centimeters. GN is also 6 centimeters, Fn is also 6 centimeters, because all of those sides represent, the radius. Fd is the radius to the first second. Dg is the radius of the second second. Gn is also a radius of the second second. And F is a radius of the first second. So therefore, this particular quadrilateral is a square because all sides are equal. But it doesn't end there. Remember that the diagonals of a square bisect each other as well. If you look at those two diagonals, FG and ND. So FD is a radius, so is DG, so is GN, so is NF. And as I've already indicated that they are all equal, therefore FDGN is a square.
Yes, sir.
Now, how are the diagonals of a quadrilateral related? How are the diagonals of a quadrilateral related? I've just given you an answer now. What is the relationship between the two diagonals? Bandra, your hand is up. You want to answer that question? What is the relationship between the diagonals of a quadrilateral? Of this quadrilateral?
Aren't they all 90
Bandra,
degrees?
right?
Aren't they all 90 degrees, sir?
The diagonals of this quadrilateral is Bandra.
Aren't they all 90 degrees?
The diagonals of the quadrilateral,
the
the square in this case, bisect each other. So what does that tell us? It tells us that at the point K there, you'll have 90 degrees. So the diagonals of a square bisect each other. That should be our conclusion when it comes to this particular activity. The diagonals of the square bisect each other.
Oh, okay. Yes, sir.
And I'm not going to waste time. I'm just going to go to activity 2, where we need to also construct. Now, read the activity carefully. Construct 2 intersecting circles, one with a radius of 6 centimeters, and the other with a radius of 4.5 centimeters. Now, these 2 circles will be different and will not be equal. Why? Because the radius of each circle, in this case, is not the same. The radius of the first circle is 6 centimeters. The radius of the second circle is 4.5 centimeters. Label the centers of the circles S and T, respectively. Label the points of intersection J and R. Now, at this point, you should be able to now draw the line segments to join S and J, J to T, and T to R, and of course, R to S as well, just to form a 4-sided figure, which will be known as SJTR. Once you have done this, draw diagonals of this quadrilateral and call their point of intersection B. So you are drawing now 2 circles which are not of the same size. The first one will have a radius of 6 centimeters. The second one will have a radius of 4.5 centimeters. Now label the centers. Very important. The first one is S. The second one is T. Label the points of intersection. Remember where the 2 circles meet. They will meet at J and R respectively. Thereafter, as you did with the previous activity, you can draw the line segments that join S to J, J to T, T to R, and R to S to form a quadrilateral called SJTR. Now, In the same note, you will draw the diagonal. So I'm just going to move faster now. I've given you a chance now. I think you should be faster than before. And if you have done your work correctly, you should be able to come up with a structure of this nature. This is what you will have. As you can see, the first circle is smaller than the second. Why? Because the radius of the smaller circle is 4.5 centimeters, and the radius of the bigger circle is 6 centimeters. Now, this is a structure that you will have. And of course, at this point, I can ask you to measure and record the length of the line segments ST, SV, VT, JR, JV, and VR. But at the same time, you can measure the size, measure and record the size of angle JVT, measure and record the sizes of all those angles, angle SRT, angle RTJ, sorry, angle TJS, and angle JSR. Once you have measured them correctly, once you have measured all of these sides and angles correctly, you should be able to see and be able to define the type of quadrilaterals that we have. Once you are done with the measurements, they will be able to guide you. So the question is, what type of a quadrilateral is SJTR? And how are the diagonals of this quadrilateral related? Now, without any waste of time, I know that we are okay, let me carry on. What type of a quadrilateral is this? Can anybody just, even by inspection, if you have not finished measuring the angles as well as what type of a quadrilateral is this? What does it look like? What type of a quad is this? Yes, 3 participants, their hands are up. Tino, okay, all right, Tino, hand is down now. Adam, you can come in.
Hello?
Right. Is there any
Okay.
other person who can come in other than Adam? I know Adam, we've given you a chance twice now. Can we get another hand? Let's broaden participation.
Hi.
What type of a quadrilateral is this?
Can I answer?
Yes, anyone at all?
I think it's a kite.
Let's go to Danny. Or Danny. Let's go to Danny. All right, Danny, we've lost you there. Anyone at all?
I think
The
it's a
host can
kite.
allow anyone to speak. Excuse me. I just want you to tell me what type of a Tino, please come in. You can speak, Tino. I'm listening.
It's a kite, sir, because
I can't hear anything from your side, Tino. If you can, I cannot hear anything at all. Right.
Can you hear me now, sir?
We are going to conclude by saying this is a kite. SJRS is a kite because it has got only one diagonal of a kite that bisects the other. So the properties of a diagonals of a kite, only one diagonal bisects the other. So in this case, ST bisects JR. So SJRS is a kite. Without any waste of time, let's continue to visit the links that I've given you on the screen there. And as I've said, we will work with we've concluded our work on construction today, and we will look at the 2D shapes next week or in the next lesson, so to say. And of course, if you have any additional information or if would like me to send you any more work or explanation, WhatsApp me on 082 623 2148. And of course, our Twitter page, at Africa Team Geeks, as well as our DBE site. Let me take this opportunity to thank you very much indeed for being part of this lesson, as well as thanking the participants, as well as others who were listening from different parts of our provinces in the country. Thank you very much indeed. Until we meet in the next lesson. Hasta la vista.
Thank you, sir.
Thanks, sir.